Well, we consider paper 1, which was taken November 2019, and the paper is November 2019, and the paper is 2.5 hours. So I want to start with question 17. This is a section 2 question. It reads, a rectangular water tank measures 2.4 meter long, 2 meter wide, and 1.5 meter high. The tank contains some water up to a height of 0.4 meter. Yes, up to a height of 0.45 meter. Part A, calculate the amount of water in liters needed to fill up the tank. 3 marks. Part B, an inlet pipe was opened and water let to flow into the tank at a rate of 10 liters per minute. After 1 hour, a drain pipe was opened and water allowed to flow out of the tank at a rate of 4 liters per minute. Calculate the height of water in the tank after 3 hours. 4 marks. Roman 2, the total time taken to fill up the tank. The total time taken to fill up the tank. So let's see what our solution should be for that particular question. Now, a rectangular water tank measures. So first, let me sketch the water tank. So I have this, have that, and this. Let's try to sketch. Let's try to sketch this, and this should be parallel. That should be parallel as such, so that this is that way. Okay. Then it's a rectangular box. Let me bring it down now, like this, like that. Yes. Yeah, I have this now. And first I should bring this. And so it's this. It's that. Yeah. Yes, so this is my box. This is my box. That's my box. Yeah, that can serve the purpose for now. So yeah, that can serve the purpose for now. So we are told that it measures 2.4. So we'll say this is 2.4 meters from here to here long, and then wide is 2 meter. So this is 2 meters. This is 2 meters, and then high is 1.5 meters. Now that's the tank that is supposedly, that's the tank that is supposedly containing water. It is the tank that is supposedly containing water. Yeah, that's the tank that is supposedly containing water. So yeah, let's do with that for now. So we are told the tank contains some water up to a height of 0.45 meters. So as we begin, there is some water up to some point, we would say here. So already there's water. There's some water. If we take it, there's some water from already taking a height of 0.445. Let me say 0.45 meters. Yeah. Then calculate the amount of water in liters needed to fill up the tank. So what we are asked is the amount of water in liters needed to fill up the tank. Already there is some water, but then we are asked what is needed to fill up the tank. So part A, will be solution to part A. That will be in meter cubed, that will be 1.5, which is the height from here to here, minus the height from here to here, so that we get this difference. Because the volume of water needed will be this difference now from there to there. So minus 0.45 times 2 times 2.4 times 2 times 2.4. That will give me the amount of water that is needed to fill up the tank. And if you work that out, you should be able to get 5.040 meter cubed, which if you change if you change it to liters, it is 5040 liters. 5040 liters. Yeah, that's part A. Part B. An inlet pipe was opened and water let to flow into the tank at a rate of 10 liters per minute. So this is part B. So inlet pipe, the rate is 10 liters per minute. After 1 hour, a drain pipe was opened and water allowed to flow out of the tank at a rate of 4 liters per minute. Drain pipe, that's outlet pipe, or drain pipe as we may call it, 4 liters per minute. 4 liters per minute. 4 liters per minute. Calculate the height of water in the tank after 3 hours. Calculate the height of water in the tank after 3 hours. So what we are going to do is to first we realize that the inlet pipe was allowed to flow for an hour before the outlet pipe was open. So first we need to get the understanding of the amount of water that went into the tank in that particular 1 hour before it was before the outlet pipe was opened. So that will be, because we know this is the amount of liters of water that was there before the inlet pipe was opened. Then after opening it, we then add water flow in 10 liters per minute, and it was open for an hour. So that means that in that particular hour, the inlet pipe had given us 60 times 10, which is 600 liters. So in 1 hour, in that 1 hour, there was an addition of 600 liters to this, to what was here. So we are going to add, so what was here is given by, what was there is given by 0. So volume of water in the tank at start, let me say at start, it will be 0.45 times 2.4 times 2. And that should give you about, if you work it out, it should give about 2.16 meter cubed, which you can change to be 2160 liters. And change that to 2160 liters. Then I'll add this to this so that I know the amount of water that was in the tank just before I opened the outlet pipe. So I'll be having 2160 plus 600. That gives you about 2760 liters. So we have 2760 liters before I leave, I allow the outlet pipe to start flowing. Then what then happens is that so this is the amount of water that is there after we have poured in more. But then the question is asking, calculate the height of water in the tank after 3 hours. So let's see. After 3 hours means we are now adding them 2 more hours when they are running concurrently, when both the inlet and the outlet pipe are running. So we see that in 1 minute, first we reason that in 1 minute, let me say, just say, where's my duster? It's here. Let me just say, the difference, because the inlet pipe is giving us 10 liters in a minute, and the outlet pipe is withdrawing 4 liters in a minute. That's a net of 6 liters. So we can say that in 1 minute, we're having 6 liters in the tank. We're having an addition of 6 liters in the tank in 1 minute. So we want to see for 2 hours, and 2 hours will now be 120 minutes. So that will be 120 minutes will give us 120 times 6, which is 720 liters. So in those 2 hours, we are expecting 720 liters to get into the tank. So we'll be adding this 720 to what was in the tank when we just, which is this, when we were starting this. So the total will now be 2760. Now, this is the volume of water that will be in the tank after 3 hours now, plus 720. And this gives me, so it's 2760 plus 720, 08, 3480. We get 3480 liters. 3480 liters. But the question is asking us, and see, 3480 liters is equivalent to, say, 3.48 meter cubed. So the question is asking us to calculate the height of water in the tank after 3 hours. We'll have to divide this by these measurements here. So that will then be 3.48 all over 2.4 times 2. And that should give you approximately, 0.725 meters. 0.725 meters. Yes. So that's the height. That's the height of water in the tank after 3 hours. Okay. Then we are asked to calculate the total time taken to fill up the tank. Total time taken to fill up the tank. So we know that already up to now we have taken 3 hours since we began, because the first inlet pipe allowed water in for 1 hour, then an outlet pipe joined, and they jointly pumped in and out water for 2 hours. So we are asked to find total time taken to fill up the tank. So we see that up to now, this is the amount of liters of water that we have in the tank. Up to here, this is how much water we have in the tank, 3480 liters. But what is the capacity of the tank? Because if we got the capacity of the tank, then by getting that difference, we would then know for how long again should the two pipes flow to fill the remaining volume. So once we get that, then we would add it to 3 hours that we have already taken to get our answer. So I'll rub here. And so now what I'll do is to try to see what is the volume, what should be the total volume of this. If it's to be full, then what is the maximum capacity? Then that should be, the volume should be, when full, it should then be 1.5 times 2 times 2.4. So this is 4.8 times 1.5. 4.8 times 1.5. If I remember working that out, if you work that out, you should be able to get total amount of water in the tank initially by multiplying that should give you about 7.2. Should be about 7.2 meter cubed, which is 7,200 liters. That's what we should have when it's full. But it's not full because this is the much that is in the tank. So we get the difference as 7200 minus 3480. Again, that difference 34 minus 3480. 7,200 minus 3480. That has to be, did I work it out? Let me see. That has to be, okay, let me see. So it's 7,200 minus 3480. That is 0, 2, 7, 3. It's 3720. So we should be having 3720 liters. Now, this is the volume of water that is left for the tank to be full. So, because we know that when both pipes are open, then they leave a net volume of 6 liters. Then we would want to know how long then would we take to gather this. So, if in 1 minute, if in 1 minute we gather 6 liters, in 1 minute we gather 6 liters. That means in 1 hour we gather 360 liters. That's what we gather in 1 hour. So if 360 should give us 1 hour, then what should 3720 give us? Then 3720 liters will be 3720 times 1 over 360. Over 360. And that is, if you work this out, it should give you about 10 and a third. If you work that out, it should give you 10 and a third because already this goes with this. So we already see this can go there 10. So it's 10 left, 12 over 36. So that's 10 and a third. 10 and a third hours. 10 and a third hours. So it would then mean that the total time taken to fill them, because this now, how long we should wait after the initial 3 hours. So it means that the total time that it has taken to fill the tank will be 3 hours past this. Yes. So that will be total time. Let me just add that without rubbing. So if I add 3 hours there, for other 3 hours to this, I'll be talking about 13 and a third hours. 13 and a third hours as the answer. for that particular part. A third is a third of 60. A third of 60 minutes, that gives you 20. So it's 13 hours, 20 minutes. So we would say our answer is therefore 13 hours, 20 minutes. And that's the answer. So that's what you're expected to do. If you followed that the way I've just shown it, then you are expected to score full marks. So if there's a comment, there's something that you may need to highlight, or you want to be clarified, leave a comment in the comment section. And for now, you follow me to my next video.